Assalamu alaikum students. Now continue the previous lecture number 16, now lecture number 17, grade 11. So I am going to continue this from the same point. So students, I told you in the previous lecture that energy of 2p and 2s same, energy of the 2p and 2s same, this is the reason of previous lecture. 2p and 3s is same, but you have to fill the orbital which has the low value of n, means principal quantum number. So value of 2p, 2 is less and 3 is more, that's why I start 2p and 3s. So these rules you have to must obey. So I'm going to go now here the rules which is called Aufbau's principle. Please, you have to draw this one. Aufbau principle. According to this principle, the electrons are placed in sub-energy levels in order of increasing energy values of sub-levels. According to this principle, Aufbau principle, the electrons are placed in energy sub-levels in the order of increasing energy values of sub-levels. Already in the previous lecture number 16, I draw all things. So this is called Aufbau principle. Now this is over. Second is Pauli's exclusion principle. Pauli's exclusion principle. Pauli's exclusion principle. According to this rule or principle, no two electrons in the same orbital, no two electrons in the same orbitals can have the same value of the quantum number. This means that when you are filling the, suppose I am going to fill the S and electronic configuration of helium, atomic number 2 for the helium, and I am using this sequence according to the Aufbau's principle. So according to the Pauli exclusion principle, when you are accommodate more than one electron in the same orbital, their spin must be opposite. Must be opposite. One should be upward and other should be downward, clockwise and anti-clockwise. One should be upward and other should be downward. So example is given here. If you see how it is going to be explained. So this is the n is equal to 1 and we are accommodating 2 electrons. This is for the first electron. This is for the first electron when n is equal to 1, n is equal to 1, this is a s. So L will be is equal to 0, s means. L will be is equal to 0, so n will be also 0 as we done azimuthal quantum number and magnetic quantum number. When the n is equal to 1, then L must be 0. This is called S subunity level, and M must be 0 because there are no degenerate for the S. So students, that is why S has a 1 electron, so it will be a positive half. So spin upward. Upward spin like this. For the second electron, again n is equal to 1, L will be is equal to 0, and again n will be is equal to 0, so S will be minus half and spin must be downward. The spin must be downward. So I told you that when you are accommodate electron in S, 2 electrons, so must have, one has a upper spin and the other has a downward spin according to the spin quantum number. And students, if you have only 1 electron, means for the hydrogen, so there is only 1, so there will be a 1 electron, but this 1 electron only means upward spin. Don't write single electron in downward spin. Don't write single electron in downward spin. It should be in upward spin. So this is called a Pauli's exclusion principle. No 2 electrons in the same orbital can have the same value for the 4 quantum numbers I told you example, and so this orbital have a maximum number of 2 electron with opposite spin. Such an orbital is said to be completely filled. S has ability to accommodate only 2 electrons. So this is a completely filled. This is a half filled, completely filled, and may contain single electron, and it should be unpaired with the upper spin. So this is about the Pauli's exclusion principle. Okay. Number 3rd. Number 3rd. Hund's rule. It's very important. Number 3 is Hund's rule. Please listen me very first statement, then I'll explain and I will give example also. If we have a 2 orbitals with the same energy, same means they are degenerated. So I am going to give you example about the carbon atomic number 6. So according to the Aufbau's principle, 1s, and there are 2 electrons must be opposite spin according to Pauli's exclusion principle, 2s according to this arrangement, and again there must be 2 electrons, 1s2, 2s2. P has 3 degenerated orbitals with the same energy, 2px, 2py, and 2pz. P has three degenerated orbitals because we want to accommodate 6 electrons. 2 and 2, 4. Dear students, P has total 6 electrons. 6. It means that 2 can accommodate here, 2 can accommodate here, 2 can accommodate here. And if I am going to write the electronic configuration, so there are remaining 2. So it means that I can put 2 electrons here. This is complete. And there should be 0 here and there should be 0 here. It means that all are paired. There is no unpaired electron if normal electronic configuration I am going to write. But listen me carefully here, this rule. This is not true. This is wrong. This is wrong, so I am going to omit. Yes. According to this rule, if we have 2 orbitals of same energy, means degenerated orbitals px, py and pz already I have written, and we want to introduce the more than 1 electron. Yes, I accommodate in the previous 2 electrons which are more than 1, then should be placed in, this very important, placed in separate orbitals with the same spin rather than in 1 2px 2 electron with a different spin. It means that, students, you have to fill 1 electron with the upper spin in 2px and 1 electron in upper spin the 2py, make the 2px, 2pz0. This is the correct. Don't put 2 electron in the x with different spin. But if you have more than 1 electron, if 1, okay, no problem. If there are 5 atomic number, if there are 5 atomic number for the boron, so I can put 1, I have no problem because there are 5 electron only, no 6, but there are 6. So if you have more than 1, so then you have to put separate with the same spin. If you have a nitrogen, at 7, 1s2, you can write this one, 2s2, you can write this one, then 2px, 1 electron, 2py, 1 electron, and 2pz, 1 electron. Yeah, this is correct. You have to put the 3 electron in all the degenerated orbitals with unpaired and same spin. So this is called a Hund's rule. So again I am telling you that if you have 2 orbitals, the same spin, degenerated orbitals, we want to introduce more than 1 electrons in them, then they should be placed in a separate orbitals with the same spin rather than putting them in the same orbital with opposite spin. It means that arrangement should be like this, In your book, written like this one. Like this one. This is the correct. This is wrong. Cross. This is wrong for this carbon. Carbon. Only for carbon. And this is correct for the carbon. Correct and wrong. This is Hund's rule, students. So it means that arrangement with the separate electron in the two sub-energy level will be more stable than the arrangement of like this one. You fill this one and make empty. No, wrong. So Hund's rule can be applied to predict the also valence number. Valency of an element can be predicted. Valency of an element can be predicted. Leave this. I am not talking about this one. This will not follow students. I will explain later this. Start from nitrogen. This rule predicts the valence number. So there are 3 unpaired electrons. 3 unpaired electrons. So nitrogen, you can see this is a K shell, and this whole is a L shell. 2, 2, 2, 2 L shell. This is the one K shell. So in the L shell, 2, 3, 4, 5. So last L shell, 5 electrons present in the 5th group in the periodic table. 5th A group, very first element in the periodic table. Group number 5. So dear students, total electron in the valence shell of nitrogen 5. So one chance is that it should have a 5 oxidation number. In many compounds, the nitrogen have a 5 oxidation number. Oxidation state, apparent charge. We call it apparent charge. Oxidation number, oxidation state. So oxidation state is 5. When 3 electrons are gained, 3 electrons are gained means 5 and 3 8. So the oxidation number of nitrogen becomes 3. So oxygen, this nitrogen may be pentavalent, may be trivalent. It shows oxidation number 5 and 3 electrons are unpaired. It shows oxidation number 3. Come to next element. Oxygen, atomic number 8. So 1s2, 2s2, 2px, 2py, 2pz. So 8 you have to accommodate. According to the rule, I must put 1 with upper spin in all. Like this one. This is the rule. Don't put directly 2 wrong. When the examiner see you or you are going to solve before your professor, before your teacher, if you put directly 2, then wrong. You have to put 1 each. So 2, 4, 5, 6, 7. 1 is now remaining. No, it's okay. So you have to put this one in. Because you have more 1 electron according to the atomic number 8. So you must put the 1 electron with a different spin downward in X. So students, this is the shell K, this is the shell L. 2 plus 2, 4 plus 5 plus 1, 6. Oxygen is the first member of group 6 in the periodic table, so it shows the 6th oxidation number maybe. And there are 2 unpaired electrons, so it must be divalent. This is the must be trivalent. Divalent and trivalent. This is the divalent, this is a trivalent. And if I am going to write fluorine, atomic number 9. So 1s2, 2s2, 2px1, 2py1, So this is the K shell and this is the L shell. So 9 electrons you have to accommodate. So this is a 2px2, 2, 4 and 6, 7. So one more. Yes. One more. So 2 plus 2, 4 plus 2, 6 plus 2, 8 and 1, 9. So dear students, there is a one unpaired electron. Group number 7 is the most electronegative group in the periodic table. And fluorine has a least, means smallest size, because atomic number is 7, there are 2 shells and the nuclear charge is high and the electrons 7 are more attracted towards the nucleus. Size is smallest one in this own group, so that is why it shows mostly -1. So we don't say 9, no. We don't say 9. Monovalent. Fluorine is a monovalent with a -1 oxidation number. This is about the fluorine. Now if I am going to write neon, atomic number 10, neon. So 1s2, 2s2, 2px2, 2py2 and 2z2. Count 2 plus 2, 4 plus 2, 6 plus 2, 8 plus 2, 10. No unpaired. No unpaired means no oxidation number, no valency. It is present in group number 8, inert gas, rare gas, noble gas. Complete the valence shell. So no valency is shown by the neon. So I have written for the carbon. I think you understand. This is a very important and technical terms. You should understand well. And from very beginning, I think from the April, May when we started the online classes, I told you you should have a pen, pencil and book, and you should note all these things, what we are doing on the whiteboard. So you must write down and go through these topics again and again, which are present on the YouTube. So this is now this is about carbon. There are only 2 unpaired. So the students, it should give 2 oxidation number, 2 valency. Carbon should have 2 valency. But no, carbon is a tetravalent. Carbon is a tetravalent, not divalent. So that's why this rule is not applied for the carbon. So I am going to give only one hint when we discuss the next chapter, bonding. So the hybridization is involved in the carbon students. So I am leaving this question here. Hybridization is going to be involved. So students, this is about electronic configuration. And there is one thing I want to tell you. And accommodation of electrons also I told you about this one. Suppose students we have atomic number 24. I think maybe it is chromium. Yes, maybe chromium. Atomic number 24. So when you are going to fill 1s2, okay, 2s2, this is also okay, 2p6. I am writing the general electronic configuration, not explaining the all rules. 2p6, okay, then 4s. Four S 3D. 24. 2 plus 2 4. 4 and 6 10. 10 and 6 12. 12 plus 2 18. 18 plus 2 20 and 4 24. According to this rule, you have to fill first 4s with a 2 electron and remaining electron d, and there are 10 electrons in d. According to this is correct. But students, this is unstable electronic configuration of the chromium 24. Unstable. Don't write this. The rule is that electrons have 24. I'm not going to change the numbers 24 because atomic is 24. Electrons should be 24. But what I'm going to have? I am going to promote one electron from the S to make the 3D 5. Number is same. I leave the unpaired electron S1 with the 1 and make the 5 electron to the 3D. So this is showing the stability of the atoms. When students, if you have a 4 electrons in the D, only 4, not other, in the D, I'm talking about D, and 9 electrons in the D. If there are 4, yes, there are cause, and if there are 9, so according to the stability rule, you have to promote electron from S to D, make it half filled to the 10. You have to make a half filled, and if there are 9, I think the atomic number copper, yes, 29. Atomic number of copper is 29. You can do this one also. Okay. So if there are 9 here, so you have to make 10. You have to make 10 to complete it. Leave the S half filled. Leave the S half filled and make the half filled with the 5 electrons of D and fulfill electrons of D with the 10. This is the rule only for 4 and 9 in D orbitals. So if you see the electronic configuration, so apply, this is the rule according to the Aufbau principles, and this is the formula to check which orbital you are going to fill, because it shows the energy of the electrons. So dear students, you have to see all the topics and electronic configuration and see the rules how we are going to fill the sub-energy levels. A small last topic I am going to explain, and this is very important, you will do in the second year class. Magnetic properties. There are 2 types of properties, paramagnetic and diamagnetic. Paramagnetic and diamagnetic. The substances which are going to attack towards magnetic field are called paramagnetic. And this property is paramagnetism. And this paramagnetism is due to the unpaired electron. Unpaired electron. Paramagnetic property is due to the unpaired electron. They attack towards magnetic field. And other is called diamagnetic. Diamagnetic means they slightly repel from the magnetic field. They are repulsion. And this is due to the pairing of electron. they are paired, they show diamagnetism. Those substances which are attracted by the magnetic field are called paramagnetic. Such substances contain unpaired electrons: sodium, hydrogen, iron, oxygen. Diamagnetic substances which are not attracted towards the magnetic field or weakly repel the magnetic field are called diamagnetic. Such substances contain only the paired electron, just called helium. So students, we complete here. So this chapter number 2 is finished, complete. You solved all exercise questions, and lecture number 17 we finished. Thank you very much.